Hello students. Today we'll be doing a revision class for the numericals on resistors based upon the queries asked by the students during the doubt clearing session of Google Meet. So they were facing some problems regarding combination of resistances both for series and parallel. So today we'll be recapitulating briefly for series and parallel combination as well as solve some problems. Focusing first of all on the picture showing the series combination of three resistors, as you can see R1, R2 and R3. They are connected in series and a common voltage source is connected, and the potential drop across each resistor is going to be different, so it is measured with the help of three different voltmeters, and total potential difference V will be equal to V1 plus V2 plus V3. Same current will flow through every single resistance. Now I will be showing you a couple of circuit diagrams which also represent series combination of resistance. You might be very well aware with the first one, as it is the common setup of a series circuit. But as far as the other circuit diagrams are concerned, they are also very much series combination of resistance. So the question is how to identify series combination of resistors. For that, you need to see in the circuit diagram that how many common terminals exist between two resistors. If there is only one common terminal, then the resistors are joined in series. That is the way of identifying the manner in which resistors are connected. So if there is only one common terminal between two resistors, then it is a series combination of resistance. So in all these circuit diagrams, between two consecutive resistors, there is only one common terminal. So you can have some idea regarding the different type of ways in which series combination of resistance is possible. Now I am showing you the picture for parallel combination of resistors so that it helps you to quickly differentiate between the way resistors are going to be connected in parallel. In parallel, the resistors are joined on both the ends. There is a distribution of current, so as soon as current enters every single resistor, it gets branched, and again it joins on the other end so that the total current remains the same. Every single resistor works on the same potential difference, that is V. Now this is also one striking difference between the series combination and the parallel combination. So you should be able to differentiate between the way series and parallel combination of resistance takes place. There is a branching of current. The total current I is equal to I1 plus I2 plus I3, but the same potential difference is applied across every single resistor. Now coming back again to the important conclusions for series combination of resistance. If there are n resistors of equal resistance joined in series, then the equivalent resistance R is equal to NR. The series combination of resistance is given by R equal to R1 plus R2 and so on, depending upon the number of resistors joined in series. Maximum value or the effective value of resistance goes on increasing in series combination. Same current flows to every resistance, but potential drop across every single resistor is different. So these are the important conclusions for series combination of resistors. Now let us come to the expression for equivalent resistance of a parallel combination of resistance. As I told you that in parallel combination all the resistors are joined in both the ends. So for parallel combination, equivalent resistance is given by this expression. If you are having three resistors, then 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. The resistors work on the same potential difference, but current is branched. Total current I is given by I1 plus I2 plus I3 depending upon the number of branches present in the circuit. Equivalent resistance formula is we have already discussed. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3 depending upon the number of resistors. If there are n resistors joined in series having each equal value, joined in parallel having each equal value, then Rp is equal to R by N. For two resistors, you can get the equivalent resistance formula somewhat like this. Now, these are some of the circuit diagrams that you may refer to for understanding parallel combination of resistors. Like the first one being again the usual manner in which two resistors are joined in parallel, but the other diagrams, other circuit diagrams also show how two resistors or two or more resistors can be joined in parallel. How to identify parallel combination? Both the ends of the consecutive resistors should be joined. In series, there is only one common terminal between two resistors, but in parallel, there are more than one. There are two terminals. Both the terminals of the resistors are joined to one another. In all these circuits, you will find this commonality. All the resistances work on the same potential difference, that is branching of current, and both the resistors, two consecutive resistors, are always connected on both the ends. So in any circuit, if you are finding this kind of a connection, then you should be sure that it is a parallel combination. Let us take one example to have a clear understanding of this concept. In this example, I have taken a circuit in which there is both series and parallel combination. Consider the electric circuit shown in the figure. Calculate total resistance and total current flowing in the circuit. There are in total 6 resistors, 3 in a group joined in parallel and then the last one joined in series with this combination. Now using the numerical values, this is a question that I have taken for numerical values of resistors. So taking these numerical values, I will be solving the question. So first thing that we will be doing is to draw the equivalent circuit diagram. Because unless we are having a proper circuit diagram, it won't be convenient for us to solve the question properly. So whenever you are getting a question, the first thing that you should do is to draw the equivalent circuit diagram. Only then you should be able to label every single component properly, and that will make your work pretty much easier. So now we are ready with the circuit diagram. This is the circuit diagram in which I have marked all the resistors, as you can see. So now one by one I will be considering the branches and finding the equivalent resistance in each case. So let's consider the first branch. In the first branch, if R dash is the equivalent resistance for R1, R2 and R3, R1, R2 and R3 are joined in parallel. So 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by 6 plus 1 by 6 plus 1 by 6. That gives you 3 by 6. You can cancel, you get 1 by 2. So therefore R dash is equal to 2 ohms. That is the equivalent resistance for the first branch. Now for the second branch of R4, R5 and R6, having 3 different values of resistors. Let's find out the equivalent resistance again. So again following a similar process, because even then these are connected in parallel, let the equivalent resistance be R double dash. So that is equal to 1 by R4 plus 1 by R5 plus 1 by R6. That is equal to 1 by 4 plus 1 by 3 plus 1 by 12. That is equal to 3 plus 4 plus 1 by 12. Solving it, you get 8 by 12. So R double dash will be equal to 12 by 8. You can cancel it out and you will get equal to 1.5 ohm. So that is the equivalent resistance for the second branch. Now in total we are having 3 different resistors, R dash, R double dash and R7. R dash is 2 ohms, R double dash is 1.5 ohm and R7 is already given in the question as 1.5 ohm. So in order to find out the equivalent resistance of the circuit, we have to join all these. Now all these 3 resistors are actually now connected in series. So to find out the total resistance, if we assume total resistance as R, total resistance R of the entire circuit R is equal to R dash plus R double dash equal to plus R7, because there is also R7 connected in the circuit. Let us substitute the values. So that will be equal to on taking the values of R dash as 2 ohm, R double dash as 1.5 ohms and R7 as 1.5 ohms. So 2 plus 1.5 plus 1.5, that gives you 5 ohms. So that is the equivalent resistance of the circuit. Now to find out total current, how to find it out? And anybody tell me which law we can use it? We can use Ohm's law. So we will be using Ohm's law. Total current I is equal to V by R. V is 6, R is 5. Just now we have calculated and it turns out 1.2 ampere. So this is the solution for this circuit where we have considered the numerical values. Now what if we consider a circuit where we are not having a numerical value, instead some general terms have been used to specify the value of the resistances. So one such circuit has been shown in this diagram where we are having a circuit, similar kind of a circuit having a combination of series and parallel, but now instead of having numerical values we are having general values. We are having resistors R and R in one branch, R minus 1 and R minus 1 in one branch, and then two resistors R plus 1 and R plus 1 connected to a voltage source V through a key K. We have to find out simply the equivalent resistance in this case. Even though the terms are general, steps are going to be exactly the same. I have intentionally took a problem like this because it will become easy for you to identify the steps, because the similar steps were followed in the previous case. In just the same manner we obtain the branch resistance for the first part. It comes out to be R by 2. Going for the second branch, becomes R minus 1 by 2. Now we are having 4 different resistors and all of them are now connected in series. So now we can use the equivalent resistance formula. So let us substitute the values one by one and find out the equivalent resistance formula to find out the total resistance of the circuit. We are having 4 resistors, R1, R2, R dash and R double dash. Therefore, if R is the equivalent resistance for series combination of R1, R2, R dash and R double dash. So now substituting the values, we will get R equal to R1 plus R2 plus R dash plus R double dash. Let's substitute the values. R1 is R plus 1, R2 is again R plus 1, R dash is R by 2 and R double dash is R minus 1 by 2. Let's solve it out. We can put the denominator as 1 so that it becomes convenient for us to solve. So now the equivalent resistance, take the LCM. We can solve it out. You already know how to solve fractions. So that should not be a problem for you. So now let's solve it out. 2r plus 2 plus 2r plus 2 plus r plus r plus and minus 1 by 2. So now we need to solve all the terms and see what the equivalent resistance turns out to be. Now let us do one thing at this point, put a subscript s so as to mention that this is the series combination equivalent resistance, just in case you get confused with similar terms on both sides of the equation. So Rs be the equivalent resistance. So now 2R plus 2R plus R that gives you 6R, and then 2 plus 2 is 4, 4 minus 1 is 3, so plus 3 by 2. So this is the equivalent resistance for the combination. So see, even without getting any numerical value, involving any numerical value, we have been very easily able to solve the equivalent resistance. Now let us take one example. If we substitute randomly a value for R and see what the equivalent resistance turns out to be. Let us put R equal to 2 ohms. So in that case, this will become the equivalent circuit, isn't it? So if R is equal to 2 ohms, what should be the equivalent resistance? Let us first check. This is the equivalent circuit, but let us check the result first of all, and then we will try and solve it out also, so that it becomes easy to verify. So I will take Rs equal to 6, in place of R substitute 2 plus 3 divided by 2. So what shall it become? 12 plus 3, 15 by 2 ohms. So this will become 7.5. Sorry, let me just erase it for you. It is 7.5. 7.5. 15 by 2 is 7.5 ohms. So now the equivalent resistance for R equal to 2 ohms is 7.5 ohms. Now let us see, instead of this general calculation, if we are substituting R equal to 2 ohms, whether we can get the same result. Let us begin with R double dash only. See what R double dash turns out to be when R is 2. So R is 2, so it will become 2 minus 1 by 2, that is 1 by 2, and that is 0.5 ohm. Let us see what is R dash. R dash will be equal to R dash will be equal to 1 by R dash will be 1 by 2 plus 1 by 2, that is equal to 2 by 2. So that gives you R dash equal to 1 ohm. Now we are left with the solution for all the 4 resistors taken together. Let me just clean up the space a little bit so that we can get some space for solving the values. We can get some space for doing the calculations. Yes, right now we have enough space to do the calculations. So let R1 plus R2 plus R dash plus R double dash. Let us put the subscript S. So now Rs will be equal to 3 plus 3 plus 1 plus 0.5 ohms. And on adding you get 3 plus 3, 6, 6 plus 1, 7, 7.5 ohms. See, you've got the same result. This means even if you are using general terms, there is absolutely no problem. In a similar method, we can do the calculation. So whether the question is given with numerical values or general terms, if it is ABCD ohms still, don't be confused. Now there is a task for you. Use this as your homework. Okay, this is going to be your homework for the day.